Okay, we'll go ahead and we'll get started, and welcome everybody to our June user group. My name is Wayne Welk with Automation Specialist with Rockwell, with the Reynolds Company in New Orleans. And today our topic is going to be edge computing with the Stratus ZTC Edge, and we have two guests from Stratus actually here in New Orleans with us today. So if you're joining from the web, we appreciate that as always, and we're going to try to do as much show and tell as we can over the web with the ZTC Edge servers. I'll introduce our speakers in a second. And if you're here live in the room, you're amongst a bunch of demo cases. We have the Rockwell on tour here in New Orleans this week and next week. So if you are listening and want to come in and work some labs, they're available for the next week and a half at least. So as always, we do a couple little, a couple traditional introduction slides. So kind of what's coming up next. So we did fill our slate out a bit since the last meeting. We kind of showed a lot of openings, in our last go around in May. So next month in July, we're going to do a networking update, and we're going to really talk about the device level ring DLR. And there's a new phase 2 DLR spec that kind of came out, or design implementation guide that came out about a month ago or so. So we'll really kind of dig into DLR principles and what the new phase 2 stuff brings. August, we'll have one of another Encompass partner, much like Stratus today is an Encompass partner. We'll have ProSoft come in town and do an update around their cloud connectivity, their data logging, and their flow computer, which is really the data logger and the flow computer are really the two things that would be of a lot of interest to our customers. And then in September, we'll shape up to be a power topic finally. We haven't done a power topic at all this year, so the medium voltage PowerFlex 6000. October's still open, but that's pretty far down the road still. And then, of course, nothing in November because Automation Fair. And in December, we always do what's called Best in Show. So we'll kind of give you the best from the Automation Fair if you were unable to attend. As always, our schedule is posted on the blog site, and all of our archives of previous sessions are there too. So then, a quick plug again for some other big events. The On Tour, like we said, is actually happening now. So take advantage of it while we got the equipment in town. Next month in July, we're supposed to have the Drives headquarters, which is very similar to the labs we have set up here, except for they're all Drives labs. So we'll have that for about 2 weeks. That'll actually travel. It'll not just be here in New Orleans. It'll be Lake Charles all the way across to New Orleans, across I-10. And then, of course, Automation Fair is in November in Chicago. Like we said, we'll introduce our guest speakers. So as always, we go and steal your pictures up on LinkedIn. So always put good pictures up on LinkedIn. For our guests on the web, it's always nice to get a face with a name, right? So two speakers today, Cody Brown and Cole Cranford, both with Stratus. So I'm going to let those guys introduce themselves and take it from here.
Thanks, Wayne. Hopefully everyone can hear me okay. This is Cody Brown. I'm the channel sales manager for kind of this region. My past is spent about 7-8 years and I was with Rockwell and some other folks. So a lot of the things in the room are very familiar to me. Been with Stratus since November. I'll let Cole kind of do a brief introduction of himself and his background.
Hello, everyone. Cole Cranford. I'm a customer success engineer with Stratus. I'm formerly known as a systems engineer. We just did sort of a reorg and some job title changes, but roughly speaking, I'm kind of the technical arm of the South Central sales team with Cody and one other fellow, Charlie Cornish, on our team. My background is in computer science. I was in oil and gas based out of Houston, subsea and offshore control systems for about the last 15 plus years until I came to Stratus late last year. So I was actually a Stratus end user since the 2005 timeframe, where we used the Stratus FT server for the master control stations on the offshore control systems that we delivered. So happy to be here.
Okay. And with that,
good to go. Just need to share my. Let's see here. Does that look good? It kind of looks okay. Perfect. Well, first off, thank you, the Reynolds Company, for having us here. Obviously, as Wayne mentioned, we both work for Stratus. We're an Encompass partner of Rockwell. Today, we're going to really talk about kind of modern edge computing, focus specifically mostly on our ZTC Edge, which is a new product, but we will touch on some of our traditional, what many of you may already know us from, our F2 server. We'll touch on both of those. If you have questions throughout, please let us know, and then we'll try to wrap up a little early so we can show you kind of the interface for the ZTC that we have running here live. So who is Stratus? Many of you may or may not have heard of us, but we like to say we build the world's most reliable computer and compute, not just computer, but computing now, because we have a scalable compute architecture, whether you're doing 1 or 2 VMs all the way to 30 plus. But our background, we have really started in the 80s as a kind of financial institution, telecom focused organization. That's at least where we kind of began, and providing critical uptime and availability to really expensive applications. And so we have tons of installations across the world with actually 12,000 customers actively on support today. We cover every industry from oil and gas, financial, food and bev, you name it, we're probably in that industry and providing uptime for applications. Some quick fun facts for us is 4 out of the 5 largest credit card companies use our solution on their back end. So if you went to buy Starbucks or lunch this afternoon or this morning, it's a pretty high chance that your transaction went across one of our servers. From there, we provide, as I mentioned, availability in a scalable format to pretty much every industry out there. For us, you will see kind of this transition, right? We've been providing these fault-tolerant servers and kind of an IT class device for the last 20, 30, 40 years. And today, as you can see, these two ZTC nodes are obviously looks like a big heat sink. I like to call them like the amplifier under your car for your stereo system, but they're different form factor. But our goal is still to provide simple, protected, and autonomous availability for the connected enterprise. And so simple means that you can set this solution up that we're going to talk about today for ZTC, set it up in minutes. It's super easy to manage, so you don't have to be an IT guru or an IT focused individual, an OT person. It kind of looks like something that would go in your PLC cabinet. That's because that's where it's supposed to go, right? And then for us also, if there's ever an issue or a failure, while your applications will stay running, it's really simple to restore your node to either highly available or fault tolerant via just a single button restore or just plugging in power and network cables. Protected, as you obviously it's hardened, it's ruggedized, but from a security perspective and failover perspective, we provide a lot of functionality in these boxes to ensure that your data applications stay running, but while they're doing that in a secure manner. And lastly, autonomous, right? We really want these solutions to monitor and alarm you if there ever is an issue. But if there ever is a problem, that it's really simple to replace a node, replace a unit, just like on FT Server. We'll talk about it later for those that don't know it. But both devices, both products that we have, our goal really is to provide availability in a really simple way. As I kind of mentioned earlier, we're across, here's another picture from discrete to continuous process. We're in every industry, from oil and gas to food and beverage and everything in between. If you have specific questions about maybe a use case or an industry that you serve that you may not see here, please let me know, because I think the list is pretty thorough. But there's a really, really good chance that we have a server and we're providing availability in whichever industry that you serve. So, you know, the neat thing about Stratus, I think, is one, we're kind of transitioning into more of a, you know, quote unquote edge computing company with the adoption and the deployment of the ZTC. But computing in and of itself is getting pretty exciting, right? We're seeing analytics, IIoT, a lot of this digital transformation, a lot of these buzzwords that are going on. They're actually events. There's actually things coming out of them. And what's, you know, the main thing coming out of those is data, right? There's been tons of study from Gartner to this is IoT infrastructure has kind of done a study that says there's going to be a significant increase in the amount of data that's going to be needed to be kind of contextualized, captured, and presented. And all of that's going to occur, not all of it, but the majority of it will occur outside of the data center. We have another statistic that we like to show from Gartner that says that like 70% of the data will be captured, processed outside of the data center. So we call that the edge. Anything in a facility at a production line, I want to be able to compare one coffee line to the next, or one baggage handling line is not working as well as the other one. What's going on? You know, is there an issue, programming problem, all that kind of stuff. We want to take data, contextualize it, and make decisions faster. And so thus, that's why, you know, Stratus is kind of expanding our portfolio. However, as that occurs, as all of our manufacturing facilities are becoming more automated and capturing more data, the cost of downtime is also correlating strongly with the amount of data that's coming. The cost of downtime is going through the roof. This number here is a little dated, and your application may not have as much cost per downtime. But what we do realize that it's going up, right? And we're asking people to do more with less, carry more hats. The production losses are being scrutinized, and really uptime and availability. This slide is really saying uptime and availability is as important as it's ever been. As you get more data and businesses rely on information and data to make business decisions, the impact of applications not running or not running properly is just increasing more and more and more. So, you know, what can you do about that? That's kind of the point of this slide. If you notice here, what we've done is we've taken availability on the left-hand side of this chart, and we've equated that to, on the right-hand side, the downtime per day. And so many applications, having in my past life, whether it be a tire plant or food and beverage, we'll walk into a control room and they're running their entire mixing application on a single Dell server. And normally it's under a desk. It's a tower server just running there. It seems okay, maybe not the most secure thing ever. Maybe we have put some security parameters around it, but that was what we would call a non-redundant computer, right? That application in a mixing plant I've been in was running 3 or 4 mixing applications. So half of their production was tied to one, Dell or HP server. If it were to go down, mass chaos ensues. Half the production of the plant's down. Everyone's scrambling to try to re-image a computer or get a backup, et cetera. We would call that kind of tower server a non-redundant server, and just inherently of itself, it's 99.5% available. While that sounds pretty good, that means unplanned downtime per year just for that specific application is 1.83 days. Typically, the next best solution people look at are cloud. Everybody wants to push stuff to the cloud. Where the cloud, as you can see here, Azure and AWS like to say that, or promote that they're 99.95% available, which equates to still 4 hours of unplanned downtime. We talked to a client last week in San Antonio that said that they were out of power for 5 hours, 6 hours, maybe longer. Some parts of it was worse, and so they immediately had concerns. If we had everything in the cloud and we're not capturing data, or this is an example there where it equates to 4 hours. And then the cluster solution, which a lot of people adopt. It's a good solution, we say at Stratus. It provides additional availability, but it's sort of complex to install, start up, and support at the plant level. Most of the OT folks at the plant level don't understand how the cluster is set up, configured, and then maintaining it after the fact is also a challenge. It still provides, 52 minutes of downtime a year. So here's kind of where the Stratus Zone lands. We like to say, we traditionally meet at least 5 nines availability, but if you look on our website, there's a calculator that's running and updated real time that is, normally at 7 nines, which equates to 3 seconds of downtime a year. And a lot of that downtime, if it's truly fault tolerant applications, how can there be downtime? A lot of it's, user error or patch updates or something outside of the server that's causing that downtime. So again, that's how we kind of say we provide, some of the most reliable computers in the world, because we, on a day in and day out basis, are showing live updates from the 12,000 servers that are installed throughout the world, and that are under support. We monitor and update this with downtime events. So quickly, talking about kind of industrial compute infrastructure, here's kind of a list of what we typically see, right? Traditional computing is, as I mentioned earlier, the kind of Dell Tower server running a single application. Maybe that's only running a historian, or maybe you have blade servers stacked up and you have a historian, a SCADA, a domain controller, etc. Single computer, single application. The challenge there is you have to, patch management for every server there. You have to update and refresh those servers every 3, 4, 5 years, depending on when you bought them and where they are in their life cycle. If there was a failure, there's a challenge with getting the server back up and running. And at the end of the day, you're only utilizing 20, 30, 50% of your compute resources on each one of those platforms or computers. And thus, you have a pretty high total cost of ownership. What we've seen is people have kind of transitioned to modern data center type computing. Virtualization's become a really big thing. And obviously, Stratus is a big promoter of virtualization on our servers. People are adopting thin clients, right? Like Thin Manager. I have a few of those things around here, and we'll talk about Thin Manager during our demo. You see the fault-tolerant redundancy comes to play, but you also see the support side of things that really kind of extend the life of the servers. For instance, on our FT server, we kind of average 8 to 10 years of life cycle on those servers. Working on a project for the city of Lubbock right now, they bought a FT server in 2006, and so that thing's still running. It does have failures, but because of our support, there's no downtime. We get it, back up and running promptly. But that just kind of goes to show you the kind of lower total cost of ownership as you start virtualizing, consolidating applications, etc. What we've seen, this really big, this whole IIoT digital transformation, this very far right side is becoming more and more prevalent, right? This modern edge computing, taking computing and putting it in a PLC cabinet, ruggedizing it, kind of, industrial computers, one may say, but obviously the ZTC has quite a bit more horsepower than most of those. You need wide temperature ranges to do that, but lastly, it needs to be pretty simple, right? It needs to be simple to deploy and configure and support. And so thus, IT is not absolutely required. They're part of the decision. They're part of the conversation, but they aren't required to support it in the middle of the night when there's an issue. And so that's really kind of the brainchild behind the ZTC Edge, which we'll talk about now. I'm going to pause. Is there any questions online or anything like that? Okay, fantastic. So what is ZTC? ZTC stands for Zero Touch Computing. For those on the phone, we have kind of two flavors. We have the 100i, which is kind of the predecessor to what we're showing here on the screen. It's sitting on our desk for the folks in the room. You can come up and touch it and feel it and hear after the presentation. But ZTC stands for Zero Touch Compute, and our goal has been similar to FT Server. We want to provide compute availability in an easy to support manner. And so if you see here, it consists of 2 nodes. It has Stratus Redundant Linux virtualization running across both nodes. It looks like a pair of nodes, 2 different computers. It kind of is, but it operates as a single system. We'll talk about that here in a second. But the beauty of it is that it's ready to set up in 30 minutes or less. So ready to deploy virtual machines in 30 minutes or less versus a traditional cluster solution, et cetera, which could take days and days of configuration. So here's a kind of a snapshot of a two-sided piece of paper you get when you get a ZTC system. 6 steps. That's all it takes. And in 30 minutes, as I mentioned, you can do this. So we tested this out at Stratus. We took our CFO, who obviously doesn't know anything about servers, and we took our general counsel, which again doesn't know a whole lot about servers other than protecting us legally. And we put them in a room, and we gave them a box cutter and 2 ZTCs, and we said, "Ready, set, go," and see who could finish it first. And I think the the general counsel won by maybe a minute or so, and he did it in 32 minutes. Obviously unboxing, etc. The best part of the whole story is our engineering manager, Barry Delacies, of this product, brought his son in a week later, and his son's like 11 years old, and in 22 minutes he was able to start up, get ready, set the system up, and be ready to configure and deploy virtual machines. So really, for us, setup is easy. Supporting the system is also easy. If there's ever a failure of a node, for instance, we would just ship you a new node, or you could grab one out of the storeroom, plug it in, and you just walk away. So we'll talk about some of that here in a second. So here's kind of how ZTC works. It is set up as, we have two options. We have the 100i, which we'll show this in a slide here shortly. It kind of compares the two flavors, but a 100i, which can operate as a highly available system. So it does have a failover, so that it's not bumpless seamless. There is a bump in your application, but we also have the 110i, which is the kind of, you can tell the guys in the room can see the difference between this kind of silver solution that's depicted on the slide versus what we have here in person. This product was released May 31st, and in this product, we're truly doing fault tolerant, so bumpless seamless. So the application, you can dictate, it's my application fault tolerant, meaning there's no failover, it's bumpless seamless, or is it highly available, meaning it's going to fail and restart on the other node. And how you decide that is all you have to do is click a button, and all of the highly available and fault tolerance is taken care of for you by ZTC. So kind of going back to our simplicity piece. So here you would deploy your applications. You can see we have kind of a RDS and 3 different applications running Windows. We support Windows and Linux operating systems. You load an ISO file or import OVF, including VMware. This might be something like a Plant PAX virtual image templates. Yep, exactly. Being able to import those into ZTC. But the neatest part about our configuration here is while it takes 30 minutes to plug in power, connect the two, we call these A-links. That's the kind of the keeping each other in fault tolerance mode, these two blue and yellow cables in the background. That's kind of the, we call it the mechanism that we do fault tolerance compared to our FT server, where we have 2 servers in one rack. You connect those 2 wires and then power it up, ready to go. All of the clustering, the configuration of the virtualization piece is all done in the background based on ZTC. It's just kind of a click and point engagement when you're deploying the ZTC. So I think most people know this, what virtualization is. I'm going to kind of poll the room here. Everybody okay with virtualization? Yep, okay. For those on the phone, if you hadn't used virtualization, for us, we like to talk about consolidating computing. So we always like to say like server sprawl, where that's kind of that idea where I mentioned you have a historian, a domain controller, and each one of those being loaded on an individual computer. Consolidating all of those applications into one platform, you want to make sure it's available, right? Or highly available or fault tolerant. Because if you were to, consolidate all that into one compute resource, now you have one single point of failure. So at Stratus, we like to say that if you're going to put all your eggs in one basket by consolidating, you better have a strong basket. And so that's what, when we talk virtualization with clients, to remove some of that risk or concern or fear they have of doing that, putting it on a easy to deploy, easy to configure and support hardware platform makes them sleep better at night. We hear that a lot, right? I can finally, rest easy because I have a platform that can support my, if there is an issue, I continue running until I get to it versus a scramble type mentality. And lastly, it's, the ability to innovate, right? Being able to deploy applications quickly. Virtualization allows you to be able to do that, make changes quickly, back up images quickly, disaster recovery quickly, all those type of things. Support legacy operating systems also is a beauty of virtualization. So I mentioned high availability versus fault tolerance. So just to kind of explain that a little bit further, high availability is kind of like a cluster solution works today, right? On the picture on the left, you have two nodes that are running. If there was a failure of an application on one of the nodes, the image would shut down, right? And then it would have to restart on the other node. So we have that available today in what we call the 100i or the 110i, and all that 100i is native. That's the only thing it supports. While the 110i, you can, with the click of a button, decide if it's highly available application or it's a fault tolerant application. Contrary to that, you can see on the right side, fault tolerant is state porting. It's checking. The application's running on both nodes, and it's always checking or check pointing data, state pointing data, to be able to keep both of those applications. If there ever was a failure of a single node, the application is kind of mirror image, just kind of like a fault tolerant application would be hardware wise, but here we're doing with two separate nodes.
What I could is looking at the picture, focus on the orange, right? Because you can see with high availability, again, there is a recovery time where that the failed virtual machine on one node would restart on the other node. So if you see in orange, there is a brief outage between the failure of one node and when that virtual machine restarts and is available once again. With fault tolerance, on the other hand, since both nodes are kind of in sync, doing the same thing at the same time, and roughly speaking, there is no outage. It's what we would call seamless, bumpless. If you were to lose a node, your virtual machines would just continue on without any interruption of service.
And I think the question we get a lot is, why wouldn't you just want to run everything in fault tolerant mode? Well, it has to do with bandwidth. For one, on these two nodes, right? We'll talk about the specs on each of these solutions here in a second. But a lot of times, maybe your historian is critical or SCADA is critical. But if you lost an engineering workstation, your Logic's shut down, right? It's not, you're not losing production because of that. And so there's where a good example where you could have five or six applications running here, one being fault tolerant, the other one, other four or so being HA, because they're not absolutely critical to the process. So, yeah, good point, Cole. Obviously, when the application will restart, just like Cole mentioned, there's going to be some data loss there, right? There's going to be, while that image is restarting, there's data loss, in-flight data loss, or data that is just missed while that application is restarting. So here's a quick comparison, and I won't read all of these things, but the big piece for us is the 100i, as I mentioned, is an HA only solution, set up kind of like, if you will, a cluster solution today. It has 4 hyper-threaded cores, so we like to say that means it gives you kind of 8 virtual CPUs, and thus you can really see 3 to 4 VMs running on that solution. Whereas the 110i has 6 hyper-threaded cores, so you get 12 virtual CPUs. Now, when you're running an application in fault-tolerant mode, there is a little bit of overhead that's needed in addition to your normal vCPUs you may need for your application. Obviously, to keep the image running, it needs more CPU, more CPU resources to be able to make that happen. And so that's why we beefed up the hardware there to give you some more vCPUs or additional hyper-threaded cores. But that's a big difference between the two. The next big difference is the storage, right? The 100i is 512 gigs SSD, whereas the 110i is 2 terabytes of SSD. And so, almost 4 times the amount of storage capacity there. Another a big difference is the amount of network ports available to you. Here on the 100i, you have 2 gigabit ports. For those in the room, these 2 white cables are kind of dedicated to your plant network. Whereas in the 110i, you have 6 ports, all gig, available to you. And you have, I know it says 4, it's a typo, I apologize. I found that out yesterday. And then you have 2, these A-links, because of the fault tolerance and the amount of data that's going back and forth to keep it fault tolerant. Instead of a gig, they're 10 gig. And so, but those are not utilized by you as the user. That's more to keep the state pointing in sync and keep the applications fault tolerant.
So I thought for those on the internet or on the phone that we just do a little basic description of the hardware. I mean, they can see the picture, but roughly speaking, each one of those nodes is about the size of a big textbook or maybe a car stereo amplifier, if you happen to have messed with that in any point in the past. So they're roughly about 8 to 10 pounds. The big thing here is that they're industrialized, they're ruggedized form factor, right? So they're sealed chassis with no moving parts. So there's 0 fans and all the storage is solid state. So the idea, as Cody's mentioned, is to bring that availability and the fault tolerance that Stratus has done in the past in the data center, but repackage that in this ruggedized form factor where now you can install this in your control panel or on a machine, on a skid in your plant at your remote site. And kind of handle those harsher operating conditions, right? So we'll quickly touch on those, but basically, with a ruggedized form factor in a tough environment, you need to be able to handle the environment that it presents. So specifically with regard to temperature, we go all the way up to 60 C, which is typically I think in line with most high-end PLCs and control system components. We also are pretty resilient against shock, vibration, and humidity. And the nodes themselves they run on DC power. So we include AC to DC adapters if AC is your preference. But if you are, say, a control system panel builder and you've got redundant 24-volt power supplies in your panel, you could wire our nodes up to those 24-volt buses directly and kind of run our servers with the same power distribution as the rest of the control system.
Yeah, thanks, Cole. The real thing to remember here, as you're, if you're deciding on, one or the other, again, think about how many VMs you need, and then what type of availability you need. That's really the main difference between the two. I mean, more storage, hyper-threaded cores, et cetera, but we're trying to kind of provide this scalable compute platform depending on your application, your needs. And so feel free to give us a call or Wayne, the Reynolds company, a call to have a conversation about what your application looks like. One thing that we like to talk about both on FT Server and ZTC Edge is really the support mechanism for the server, right? If you're going to buy a fault-tolerant application or a high-availability application because your application is really important, it needs to stay running, the hardware and how it's configured is really important up front. But getting you back, if there ever was a failure, getting you back to fault-tolerant mode or highly available mode between the two nodes as quick as possible in case there is another issue or another failure is paramount. It's super important. And so for Stratus, we simplify all of the support by providing a support contract for the system. The system's smart enough to monitor itself all the time, provides diagnostics, notifications if there's an issue. The system, if you're connected to the internet, is smart enough to what we call phone home, call home, and tell Stratus it's broken and tell us exactly where it is, what it needs. And within the next couple days on the ZTC, we can get you a new node. And we're not going to ask you to open up the node and fix something. We're just going to ship you a whole new node. It's included in your service contract and it'll be there automatically delivered to you. When it arrives, you just unplug your power and network cables, remove that node, put the new node in, replug network cables first, power next, and then depending on how your system's configured, it can boot on power and get back in either high availability mode or fault tolerant mode between the two nodes. It's as simple as that. On the FT server, it's a little different. We do deliver on the FT server, which we'll talk about towards the end here. We deliver that's hardware next business day. And again, so for us at Stratus, the hardware, the solution is extremely important, how it works and why it does what it does. But on the back end, getting you back when there is a failure, because it's not if. When you're dealing with electronics, we all know that, right? PLCs fail, hardware fails. Getting you back up in fault tolerant or high availability mode as quick as possible through our service solutions is really critical. A couple new features. So with the release of 110i, I'll probably have Cole touch on these next couple slides, but with the release of the 110i solution, we released Stratus Redundant Linux 2.0, and we added some really important features that we think will help out and we get a lot of questions since the release of the 100i about a year ago to add some of these features. So you want to touch on these next couple slides?
Yeah, sure. So the first one you see here is what we call our full stack monitoring package. So it's one thing to monitor the hardware itself, right? So with the operating system, the built-in features, you'll find out if you have a hardware failure. But what about your actual applications? So what about your virtual machines? How can you be sure that they're up and running and that they're available at the software level, right? So we've kind of introduced this full stack monitoring feature to provide that functionality. So now within our user interface, you can basically enable and configure alarms and thresholds that can monitor individual virtual machines or that can monitor individual applications, right? So when you set up those monitoring points, you can configure the system to alert you, whether that's email or OPC or SNMP. The whole point being that you can monitor your software stack as well and figure out if anything has gone wrong at the software application level.
So in addition to that, we've released a couple new ways to do some monitoring of your system. And so we have OPC UA server that you can easily configure from the dashboard. I guess I didn't mention that, Cole. I forget that all of the operation for ZTC is done from a web console. And so it's super simple. Cole's going to show you here in a second and demo it, but Cole likes to tell people we try to make it more like an Xbox, right? Something that's just plug and play, easy to use, one screen, very simple to monitor, which again, with Reynolds, it kind of looks Logix 5000 on the left side. You kind of have your tree of options that you can kind of drill into, but it's very much a point and click. And so here with OPC UA, you can easily configure that. You can leverage kind of the SNMP to enable alerts and alarms, or use RESTful APIs to integrate this into maybe other systems, et cetera, for your management. So we have multiple ways to monitor the solution. From a support perspective, I mentioned it's also available for the solution to call home straight to Stratus until there's an issue. Security, do you want to touch on that?
Sure, I could touch on that one. So as Cody mentioned, cybersecurity is extremely important to a lot of our customers, and we've been trying to enhance our security-related features. So in the latest release of the operating system, we include firewall capability. So if you don't have an external firewall or a protected network within the ZTC console, within the management interface, you can enable a firewall, and you can set up protection based on protocol or port or IP address. We have a number of additional features as well. So for physical security, in fact, in my oil and gas days, more security issues were caused by good old USB sticks than anything else, right? People would not know that they had some malware or virus. They would plug in a USB into their control system computer, even though they probably shouldn't, and bam, all of a sudden you got a major security issue on your hands. So of course you can disable the USB ports. You can disable the virtual CDs to eliminate that kind of exposure. And lastly, we have some new features called Secure Trusted Boot, where basically we inventory, take a baseline of your virtual machines and your applications. And if anyone should somehow modify that or attempt to inject any malicious code, then the system can detect that and would basically alarm and refuse to boot that compromised virtual machine. So again, we're just trying to provide as many tools as possible to allow our users to guarantee security at the application and OS level.
Perfect. Thanks. I threw a couple of these. I know there's a bunch of oil and gas here in kind of this region, the Gulf Coast region. I wanted to share a couple use cases. Obviously, we have tons in every industry. I just picked oil and gas because we just talked to customer a couple of weeks ago down in this way on this focus. But here's a quick architecture where customers are looking at us at Stratus as a scalable compute infrastructure across the board, right? They have ZTC, they have FT server, depending on the availability needs, but also depending on where the application is and how many applications they run. We'll talk about FT server here briefly for probably maybe 3 to 5 minutes, but it can host 10, 20, 30 plus virtual machines. And so really my hope here, and hopefully your takeaway here for this slide, is that we have this scalable architecture and scalable compute platform, whether it's a ruggedized in the panel on the edge type deployment, or in a data center, maybe at a plant making coffee, right, running 10, 20 different virtual machines in a secure air-conditioned type server class device. Here's a couple more examples, right? We've got plenty of success in oil and gas, past success on FT server, but now that we can deploy, a single purpose-built device, maybe for adding a historian in a remote application, that's all they want to run on ZTC, and they want it to be fault tolerant. So now these guys are looking at deploying many ZTC Edge devices because of kind of the form factor, footprint, etc. And the second time, I'm going to kind of cruise to FT server. So I know many of you came to hear ZTC. I think of FT server as also an edge device. It's outside of kind of the corporate owned data center. It's more on maybe a local on-prem data center. So I just want to make sure everybody's aware of what we provide here. This platform is truly fault tolerant on the hardware side. So mirrored RAM, hard drives, etc., fully fault tolerant, and the product's running in lockstep. So the solution, while it may look like two servers here, it's really one server with two halves. I like to say it operates like your eyes work, right? So you have two eyes, you're seeing one image. If you were to cover your left eye or right eye, you didn't like shut down and restart to see the same image. You're continuing to see the same image. So the neat part about how tightly integrated that lockstep technology is it allows us to use a single software license. So if you think about a cluster solution, every server you have, you need a software license for that server in case it failed over. So that really drives up the software cost when you're looking at a high availability VMware cluster solution or someone else's cluster solution. Here, the way that our server operates, you don't have to have that challenge, but also because it's truly fault tolerant hardware, there's no failover time, no data loss. I think I already explained this, but I'll touch on it again because it's probably my favorite feature that we have at Stratus is this operational simplicity. Say there was a failure on the bottom half of what we call a customer replaceable unit. We call that whole half a CRU, customer replaceable unit. If there was a failure of a CPU, you name it, inside of the CRU, we're not going to ask you to open it up and go in and replace DIMMs or replace anything like that. We're going to just send you next business day that entire half of the server. So you unbox it, you slide it back in, you walk away. You put your hard drives in, obviously, and then walk away, and it's going to get back in fault tolerant mode. I mentioned hot swappable. The neat part, the other big piece of this server that we like to talk about is, the life expectancy of the server is 10 plus years. I like to say 8 to 10 years, but I gave you guys an example. Water wastewater customer in Lubbock is running it for 13 years, still on support. Now we strongly recommend that they move forward, and we have it actually budgeted to do that. But those few things, the simplicity from an operation perspective and keeping it up and running and supported, the single software license and the life expectancy really drive that bottom bullet, which is the lowest total cost of ownership. So, again, remember, if you had a failure, it's not like you went down. You get notified via SNMP, via phone home, et cetera, that there's a problem. And a lot of times you don't even know that there's a problem until Stratus calls you and tell you there's an issue, or hardware shows up on your doorstep the next day. I mentioned the hot swappable parts, 3 sizes here, right? So for us, I like to say kind of 10, 20, 30 plus virtual machines. So in FT server, we have a 2900, 4900, 6900. Each of those have, different functionality and can support more RAM, storage, etc. Basically get a hold of, Reynolds, us. We can help size your application. If you're a Rockwell user or other software user, we have sizing tools that can help. We can help configure your application, whether it be you name your software vendor. We try to make it easy for you to size up an application to kind of get your kind of quote and budgetary things going. So I'll provide the slides to Wayne to kind of pass out after this. We have about 15 minutes. I want to give Cole probably 10 minutes to kind of show quickly ZTC, the kind of web console, the user interface, and kind of how it works. And then we'll leave probably 5 minutes available for questions, and we'll be around if there's extra questions. So Cole, can I pass it your way?
Sure thing. Thanks, Cody. Let me see if I can get this shared. see if it updates and comes through. Okay. Well, no, I'll just go with what I got. Okay. In the interest of time, this will just be a real quick look through the management and monitoring interface for the ZTC Edge. So as Cody said, the system, everything you do to the system is done via a single web interface, whether that's monitoring the system, checking on the status, if you want to create, start, stop virtual machines, backup virtual machines, access virtual machines, anything you may want to do, you point to the IP address of the ZTC system in your web browser, and you log into that management console to work with the system. So I'll quickly just take you through a couple of screens. When you first log into the system, you would see the system dashboard, which you see here. So this is kind of status of your system at a glance. What you want to see is many green circles and check boxes as possible, indicating that everything's up and running and that the system is healthy and happy. If you were to have any issues, you would see yellow exclamation points or possibly red X's, and they would be sort of highlighting either the node or the network interface that's having a problem, and they would show up in this list to give you some of those details so you can drill down from there. Further into monitoring of the system, at the system page, this is the equivalent of kind of a task manager view for a clustered system. So it gives you a holistic view of the system as a whole, so you can monitor how many virtual CPUs, how much memory, and how much storage you're using. And then you can drill down to the hardware level and look at the utilization of resources on each of the two physical nodes. Anything related to configuration of the system you would do from the preferences section. So here I've got some owner information. You would also handle your product licensing. I believe Cody mentioned all of the software, all of the licensing comes included with the system and actually preloaded. So once you configure it and boot it up initially, you simply go online and do a license validation. And once you do so, the license is active and never expires. Here's where you would set up the networking for the system. So in case there are any folks curious about what that networking looks like, the system itself needs 3 IP addresses on the management interface, right? One of those would be for node 0. One of those would be for node 1, and one of those would be for the system itself, the entirety of the dual node system. So you can just specify your IPs and subnets and gateways here and apply that network configuration, and that's really all there is to it. We talked about the 30-minute setup. This is the most difficult process, which is not that hard. So as long as you know your networking information for the system, it's just unboxing, plugging in cables, typing in IP addresses, and you're up and running. In the interest of time, I'll skip ahead a little bit. So we'll look at the physical machines tab. Here is where you would sort of track the status of each of the physical nodes themselves, right? So again, I have a row in the table for node 0, another for node 1. I can see that both have green checkboxes, so they're both running, happy and healthy. I can see that node 0 is currently operating as the primary node. And on my test system, I have 4 virtual machines configured. And you can see that in assuming that both nodes are running, 2 of those virtual machines would run on node 0, and 2 of those virtual machines would run on node 1. So that's the automatic load balancing of the system, right? So since you have 2 physical computers that are up and running, you can set the system to use all of those resources and kind of distribute your overall workload between the 2 physical machines. At the virtual machines level, anything you would do for your VMs would be from the virtual machines tab. So examples, you could create virtual machine here from scratch if you wanted to load like from a virtual media, like a Windows Server installation CD. You could import or export virtual machines. So if you had previously made a backup of a VM, you could easily restore it or clone it or create a copy. And of course, anything to do with monitoring administration of your VMs, you can do here as well. So you see I have 4 virtual machines on this test box. If you look at the status, I have only 1 running at the current moment in time. It happens to be a Rockwell Thin Manager all-in-one demo virtual machine. And you can see from the graphic that it is currently running on node 0. If I want to access these virtual machines, there are a number of ways. One of the easiest is to click the console button and actually open a console in the web user interface. And I will skip to another to show you a more common approach. So this would be, say, remote access from other HMIs or thin clients in the plant. So remote desktop is a commonly used mechanism, right? So here is a remote desktop session where I'm showing the display from the Rockwell virtual machine. And you can see that in this case, it's running the Rockwell Instant Fizz example demonstration with a kind of a soda production line. So remote desktop, that's a good way to access virtual machines that are running on the ZTC. Because keep in mind, the ZTC itself is what we call headless. There's no monitor, keyboard, and mouse where you would walk up to the unit and interface directly, right? So you would need to access from the console, from a remote desktop session, or give me a moment here, or from a thin client application. So in this case, I know it looks exactly the same as what I just showed you, but this is actually the Windows Thin Manager client running on my laptop. So in this case, my laptop is acting as a thin client device, and it's connecting to that virtual machine on node 0 of the ZTC system as far as getting the data to display. So this would be the equivalent of like, some sort of panel view type device out in your plant where, your operators may have HMI screens to monitor and control the process. Let me, oh man, this guy is in my way. See if I can figure out how to switch it. Do you know if I can move this menu bar? Let me see here. Okay, there we go. Okay, so that's the bulk I wanted to show you. Similarly, as far as monitoring and informational pages, you could look at the volumes page. This is all of the storage partitions that are created on your ZTC system. There are a number of these that are for the system itself, and then there's typically one or more volumes that are specific to that virtual machine. And you can see the first 4. These are the volumes for my 4 virtual machines. And if you notice, they are 100% in sync between the 2 nodes. That's how we handle the failover, if you will, between node to node. If you pull the power cable, if there's a power outage, or if there's a major component failure of some of the internals, right? The disks, the volumes for the virtual machines are kept in sync between the 2 nodes. So if you lose one node, the data for that virtual machine is already present over on the second node. So that virtual machine can reboot and continue on its way in the high availability case, or can just continue in a seamless, bumpless fashion in the fault tolerant availability mode. Last page to show you, networks. So here you can graphically monitor the status of all the cables that are connected to the system. You can monitor your various network links, link speeds, and networking information. Just in case you should need those diagnostics. But I know we browsed through a lot there, and we only have a few minutes left, but what I want to impress is that it's all point and click. It's all done from a web interface. Like I say, anything with the system, whether monitoring, whether it's administration, or anything with your virtual machines, it's all from the same interface. And like I say, just a point and click basis, and we think extremely easy and intuitive to use.
Yeah, great job, Cole. Just to kind of reiterate what we're looking at here. So if Cole's pulled up the Thin Manager screen, and he were on the solution that we're running today, the 100i, we were to pull power on one of the nodes, and the VM was running there, it would shut down, right? He'd lose connectivity, and in about a minute to 2 minutes, it would restart on the other node. Your application would launch, and you would have visibility back into your solution. In the 110, as comparison, if it was in FT mode, that application, it would be running on both nodes. You would do the same exercise, and you would see nothing, right? Nothing. You would see everything. You would see the application continue to run, right? You would not see it shutting down and restarting. It would just continue to do what it was doing, bumpless, seamless, if you will. And the same thing on FT server, obviously. So just kind of by comparison, that's kind of how the system would work if there was a failure. So it really kind of comes down to, when we're talking about virtualization, availability, and Stratus, is how much availability can your application handle, right? Is data absolutely critical? Or can you have a few minutes of downtime as long as it comes back up and keeps running? So that's kind of the thought process here. But that's really it from on the Stratus side. Thank you, everyone, for attending. I'm going to open it up for questions now. Cole and I are here past the hour, but we have 5 minutes here for questions. If you have anything on the chat, feel free to fire away. Let us know. We'll be happy to answer any questions here in the room.
So do you
license for this, or is this using its own proprietary VM software?
I can restate the question.
Yeah.
Yeah, the question from Sam here was, do we, you need a VMware license, or are we using kind of a proprietary system that's included with the machine? No, you do not need a VMware license. So we would refer to that, the virtualization layer as the hypervisor. The hypervisor for the ZTC Edge comes built into the operating system, and it's based off of the KVM hypervisor that's used on Linux distributions. So as soon as you unbox your ZTC, of course, you've got both nodes of the hardware, all the cables and the power accessories, wall mounts and DIN rail mounts. But on the software level, you've got the entire operating system, including the virtualization layer and the high availability or fault tolerant layers built in out of the box. No additional licenses to buy.
And you could still read in, it looks like some VMware templates.
That's correct. So there are a number of ways that you can convert. We call that, say, P to V or V to V. If you had an existing physical machine, we have a bootable ISO that you can use. You would basically boot that existing physical computer using our ISO, and you'd be able to convert it on the fly over the network and import it into the ZTC. Likewise, the same utility can be used for V to V or virtual to virtual. So say you had a VMware ESX host, you could boot that virtual machine off of the ISO and again, convert on the fly over the network to the ZTC.
So we have a bunch of machine hours for example, we've got like old 586 with some crazy old software. We use that P2V software that makes an ISO of it. That's basically fortified.
That's correct. So you're exactly right. Support for older operating systems. That's a great benefit of virtualization. And I won't claim it's just Stratus that can provide that. That's virtualization in general. So like you say, usually there's a mechanism to convert an existing physical machine to virtualize it, and then you can go on running that operating system for some time to come. Now, for full disclosure, there is a list of supported operating systems for the ZTC, because of course we can't go back for forever. But roughly speaking, any of your common Windows Server operating systems, Windows Desktop operating systems, or most Linux distributions, you could support those operating systems if you were to virtualize on our platform. We have a list of the exact, we can get it to you if you want to check your specific one.
If you have a physical node go down, have to replace one of the two components, you have to reload the software for all various virtual.
A great question. So to recap, in case you couldn't hear it, the question was, if a node were to fail, when you replace it, do you have to manually reload the new node or reload those virtual machines or applications to get it back in sync? And thank goodness the answer is no. It's all automatic. So that's a part of the simplicity piece that we've aimed for. It's plug and play. So as soon as you replace the failed node with that new node, as Cody mentioned, you would plug in your networks and then plug in power. The new node will automatically boot. As part of that boot process, the nodes will communicate with each other, and it will basically, the system will recognize, aha, I have a new node here. He needs a copy of all of my data, and all of that data will be automatically pushed across the two network links between the two nodes, so that all of your VMs and applications are automatically copied. So it depends. I would say it depends on the size of your virtual storage, but roughly speaking, I'll give an example. So we had a 250 gig image, virtual image that we were testing with, in fact, just yesterday. And that was on the 110i platform. And in that case, the resync, it actually occurred in 2.5 or 3 minutes. It would be slower on the 100i because you have 1 gig instead of 10 gig interconnectivity. But again, roughly speaking, 5 to 7 minutes for an intermediate sized virtual image.
And obviously it's scalable, right? We've seen if it's less, it's less. So it's as fast as the ZTC can talk across these links. Really is kind of one of the major factors. And so we've seen it restart an image in less than a minute. Right. I mean.
Oh, right. So we're talking about the node replacement case. But if there were a temporary outage, then the system is able to do a differential sync. So you wouldn't have to copy the entirety of your virtual image. You would just recognize what was new, and it would basically sync up much, much faster in that type of situation.
I got 2 online actually.
First was a max number of recommended VMs using HA only for the 110, high availability only on the 110. So how many VMs can you run?
Okay, so on the 110, so that's with a 6-core hyper-threaded processor. So that gives you 12 virtual CPUs to work with. So I'm going to have to make some assumptions, but let's assume for the moment that an average virtual machine will utilize 2 virtual CPUs. In that case, you would have 12 vCPUs to work with, so you could support 6 virtual machines running in HA mode. Now, to be specific, if you were to enable a virtual machine in fault-tolerant mode, any fault-tolerant virtual machine will require another 2 virtual CPUs that are utilized by the system. So that's why there is a hardware cost associated with enabling fault tolerance. So as Cody mentioned, what you would typically want to do is for your most critical applications, that you have seamless bumpless is a need, you have no ability or no tolerance for downtime, fault tolerant, right? But you don't typically want to go fault tolerant across the board, just because then you're using more resources than you might necessarily have to be using.
The question was about accessing virtual machines. So I think you kind of touched on that a little bit in Thin Manager and remote desktop, but basically if you have 10 virtual machines running, how do 10 different access?
Okay, so each of those virtual machines would have an independent presence on your network, right? So I touched on the 3 IP addresses that our system requires. Remember that was node 0, node 1, and then our system as a whole. Each of your virtual machines would have independent IP addresses out on those business networks. As Cody mentioned, there are 2 physical business networks on this model, and on the 110i, there are 6 physical business networks. So in that case, all of those virtual machines are out there on your business network, just like any other physical machine, just like say your office PC, if you're hooked in, to the corporate LAN. So from those remote terminals, whether that's an HMI station or maybe it's someone's PC in a thick client case, you would just point your thin client application to the IP address of the virtual machine that you would want to remotely access. In one case, that would be typical for a remote desktop scenario. If you were to use a content delivery system like Thin Manager, then it's possible to manage all of that content delivery from a single application and have it automatically deliver that content to certain terminals throughout your plant. But either way, the content would be served up by a number of virtual machines, and you would direct your client devices to get their content from those VMs.
I do want to kind of touch on, I know if there's more questions, keep asking them. These are great. I do want to touch on one thing I'll provide to Wayne is we have 2 kind of white papers written by Rockwell. One was Thin Manager did a characterization test on our ZTC on this node. They're actually in the process of doing the same for the 110i. But they kind of loaded it with a configuration that they explained, and then they added clients until the performance degraded, and then they took screenshots of Task Manager, et cetera, to show that. And so we can provide that. And then there's a great article written by, I think it's Rich Engel. He's a GOTC, Global OEM Technical Consultant on the West Coast. He wrote a really great write-up for us on the ZTC for OEM specifically, and how it kind of fits. But either way, both of those articles are really great to kind of look at and kind of get a use case in your head, but also some of the testing that they've been done by some pretty smart folks on Thin Manager side, but also Rockwell side for different hardware and setups.
Okay, the last thing I would want to mention is let us know how we can help. So keep in mind, we don't expect you to just see a demonstration and think like, oh, that's what we need. Engineers, they want to test, they want to see it in person. So let us know. We have loaner systems that we can ship to various customer sites. We can work with you to set up your virtual machines and get a proof of concept test going. And that holds for both the ZTC Edge platform and for FT Server. So
and Reynolds Reynolds actually has a ZTC Edge here that they own, that they can do demos, et cetera, for as well. Yeah, like Cole said, we're happy to come back to wherever you guys are at, Lafayette, New Orleans, wherever it may be, to support any kind of conversation, no matter what the architecture looks like, from a FT Server all the way down to ZTC Edge.
I can attest that it really was less than 30 minutes to set them straight out the box. So I could do it. I know you can do it. All right. Well, we'll close it out. appreciate everybody attending as always, live and on the web. Cody, Cole, thank you very much.
No, thank you very
for
much.
coming in
Yeah.
town and presenting. So thanks again. We'll see you guys again in July. Thanks.